In this video, we will learn how to create an AI model in under 5 minutes using AutoAI. As a data scientist, I usually write Python or R scripts to create my models, which can take hours, days, or even weeks depending on the complexity of the problem. Let's see how AutoAI can make our lives easier. In this case, our goal would be to predict truck battery failure, which is the main cause for vehicle immobilization and impacts a number of industries, including transportation, retail, mining, and others. To do so, we're going to use our battery dataset, previously loaded in our Watson Studio project. Each row of this dataset corresponds to a truck. Each column is a characteristic of such truck. For example, we have the number of kilometers driven, also the total driving time, the total idle time, the number of starts, the average voltage of the battery, and also the average ambient temperature, which turns out to be very important because battery load will be higher under cold weather. Finally, we have an attribute called class, which tells us whether they replace the battery for each individual truck. Now, this is a classic example of a classification problem. In this case, we have all numeric features, and the target variable is categorical, having two potential outcomes, true or false, depending on whether the battery was replaced. Now, I'll go ahead and create a new AutoAI experiment. I'll give it a name, say truck battery prediction, and I will select the battery dataset from the project. Notice that the data types are automatically detected by AutoAI. Now I will select the target variable, which in this case is class. Since there are two potential outcomes, either true or false, this is a binary classification problem. Also, many parameters can be customized, including the size of the training data split, the columns that will be included as features, the positive class, the optimized metric, the set of algorithms that will be used, as well as other parameters for feature engineering and hyperparameter optimization. After kicking off the experiment, AutoAI will run different algorithms, different hyperparameters, and different feature engineering strategies. And it will compile the results and give me the best models. Now, it is worth mentioning that data science is a very experimental discipline, so very often you wouldn't know which algorithm is best unless you try a few of them. For example, random forest, XGBoost, or support vector machines. Now, each algorithm has a set of hyperparameters, which are the knobs, dials, and switches of your models. For example, the number of trees in a random forest, or the maximum depth of a tree, or the regularization parameter in a logistic regression. All of these are hyperparameters. Now, changing these parameters can drastically affect the performance of the model. So, this becomes a very challenging optimization problem. Different techniques have been devised for hyperparameter optimization, including grid search and random search. In addition, us data scientists usually like to experiment with different feature combinations, such as computing the logarithm of a feature or the ratio among two features, and so forth. If I were to implement this manually, it would take me hundreds of lines of code to train each possible algorithm, then implement a search method to find the best hyperparameters, and then try out different combinations of features, and finally compute all quality metrics and compare among all the models. Fortunately, AutoAI just did all of that for me. Here, I can see that pipeline 4 is the one with the highest quality. I can dive a little bit deeper and get the accuracy, precision, recall, F1 measure, and the ROC curve. Also, the confusion matrix is shown to analyze the impact of false positives and false negatives. Moreover, I can check which are the most important features. In this case, new feature 0 was the one with the highest importance, followed by the average voltage, the idle time, and the number of kilometers. Now we can take a look at all the feature transformations, and we can see that new feature 0 is in fact a function of the number of kilometers, the drive time, the average start time, and the average voltage. Now I can save this pipeline as a model, which would allow me to deploy it on the cloud, or I can save it as a notebook, get the code, and further refine the models. Once the model is saved, it can be deployed by creating a new deployment. After giving it a name, the model is now deployed. Watson Studio also gives you the code you need to score the model in different languages, including Java, JavaScript, Python, and Scala. You can also test the model with different values and get predictions from the UI. Notice that if we change the drive time from, say, 1000 to 10,000, the prediction also changes from false to true, which makes sense because the more time you drive the truck, the more likely it is that the battery needs replacement. So, congratulations! You just learned how to use Auto AI to train and deploy a high-quality model, and in less than 5 minutes. Would you like to try Auto AI yourself? Create a Watson Studio account for free today. Subscribe to our channel for more videos and tutorials on AI, machine learning, and data science. Thanks for watching.